When a force is applied to an object, only three things can happen. The engine's weight is trying to slice through those bolts. That's a shear force. Understanding these three distinct outcomes is the foundation of all engineering. And once you see it, you'll start to view the entire engineered world a little bit differently. From the bridge you drive over to the chair you're sitting on. And this isn't just theory, it's the practical knowledge that separates a good design from a failed one. I'm Brogan Pratt, and for over a decade as a robotics and engineering educator, I've taught these core principles to build successful, robust designs. Today, I'm going to run you through these three reactions to force. We'll start with why things stay put, look at how they move, and what happens if they break or they bend. We'll use simple diagrams and real-world examples that you see every day. So the first outcome is that the object remains stationary. It doesn't change at all. And for many engineers, this is the absolute goal of why we're doing this. So this obviously happens when all the forces are at equal points. So if we look at a standard box here that was just sitting on the ground, you have the force of gravity pulling it down, and you have an equal force or normal force pushing it back up. This is the first common scenario that happens. You can kind of think of it like a tug of war, where both teams are pulling with the exact same amount of strength. Your net force is zero. It stays in equilibrium. There's no change to where this rope is actually going to go. So the second outcome is that the object itself actually moves, and this can happen in two different ways. First is translation, which is another fancy word for sliding, and the second one is rotation. So for a translation slide, you may have had a box that started at this position, but it eventually moves itself over in the opposite direction. This would be a translation, and you think of this, like pushing a book across a table. Eventually, if you push with a force that's greater than the force of that friction, the object is going to slide, or it's going to translate. Now, mechanical engineers often want to be able to create and control this kind of movement. You can kind of think of it like a piston in an engine or an elevator going up and down shaft. Now, the second type here is rotation. You may have started with a box like so and finished with a box that's in this orientation. At this point, you're now rotating or rotation along a specific axis. Now, you can think about this like a wrench being used to turn a bolt. The bolt would be that pivot point. You've got doors on hinges, you've got wheels on an axle, you've got seesaws. Those are all examples of engineered rotation. Now, the third outcome is that the object itself actually changes shape. And there's 6 really common ways that an object can change shape. And in most cases, engineers design things so they don't change shape. But sometimes you design things that they do intentionally. And the first type of force is something called compression. So we've kind of squished up and made our object a little bit more compressed inside of the space that we were originally given. You can think of this kind of like a car's crumple zone. It's designed to compress during that collision. And by deforming, it absorbs a lot of that energy from that crash and protects those passengers that are inside. It's a change in shape by design. Sometimes it's not by design. You can also think of this when you're crushing down an aluminum can. You compress that down. Next, we've got deflection. And in deflection is when an object bends under load, but it returns to its original shape once that load is removed. A great example of deflection is a diving board. You're using some sort of spring that's inherent to the material that once you bend it, you store up that energy, and when you jump, that energy is released, and it's designed to be able to deflect and return itself to its original point. So you can think of deflection as kind of a temporary changing of shape. A non-temporary example of deflection might be something like we've put a deformation into our box. So this would be a more permanent version of deflection. It's a permanent change inside of a shape. Play-Doh is a great example of a deformation object, or clay is another great example of deformation of an object. Another type of force is something called shear. And shear is a sliding or cutting force. So you can kind of think of it like scissors. The two blades are applying force parallel to that paper and they shear it in two. Or you've got bolts holding an engine to a frame. The engine's weight is trying to slice through those bolts. That's a shear force. Or if you have a screw put into 2 pieces of wood and is being compressed on this way, that is a shear force. Racking is another type of structural deformation. You've probably gone up to a poorly built bookshelf before, push it on the side, and you can turn the whole thing into a parallelogram. That's an example of racking. Sometimes it's temporary, sometimes it's permanent. And this is usually why, to avoid racking, we add things like adding in diagonal braces on top of our pieces to be able to stop things from racking. And you've probably seen those in some of furniture you've looked at before or on tables. And the last outcome with the object is a fracture. And engineers try to avoid a fracture as much as possible. It's a catastrophic failure. This is your ceramic plate shattering. This is your 3D printed part breaking apart. And it tends to happen when an object is overloaded. So the force that's applied to this object has exceeded that material's internal strength and it breaks. So as a quick review, option number 1, the object stays at rest and nothing happens to it. Object number 2, it moves and it either translates or it rotates. Sometimes it's intentional, sometimes it's not intentional. And option number 3 is the object changes its shape. It compresses itself, it deflects, it deforms, it shears, it racks, or it fractures. And now as you know some more terms to play around with, have some fun taking a look at the world around you. Look at the chair you're facing on and see how it's designed not to move. Or perhaps it's a rotating chair and it is designed to rotate and move around. It's got wheels. It's designed to translate. Look at suspension on a car or on a bike. It's designed to deflect and be able to spring back and bounce back with those initial forces. And once you start viewing the world through those lenses of the different forces and the 3 types of outcomes that can happen when forces are applied to objects, you really start to see the amazing engineering that goes into all of these designs of everyday things. So I hope you found that helpful as an overview in the types of forces that can apply to objects, and best of luck in your next project.